house with, and like kind of a kid in a like a goldfish bowl with a cat watching it kind of an effect. Let's give them something good. So we have this whole setup now where you can buy digital models, and we made them really affordable at 99 cents each, so people can just have stuff to make, and we can pay designers to do it. This is an old number. It's more than that. We've got this whole community, which is kind of obsessive, well, really obsessive. We actually started this before we started the hardware company. Thingiverse.com is absurd. It's one of those things, if you're a blogger and you're looking for cool content, you can just cruise Thingiverse every day, and there's just people sharing the most innovative, creative stuff, and they're making it, and they just want you to make it yourself. They just want to have designs and have them enter the portal of your Makerbot and enter the world, and this is pretty exciting. Artists, you can think of it as like a way of entering tens of thousands of people's homes by having a good design and sharing. Interesting things will happen with brands in this space. Lots of digital design. So when you get a Makerbot, you can just make stuff. There's like, I don't know, 20 or 30 doorknobs that you have to choose from if you want to download a doorknob. Or you can download one and modify it, or if you make one from scratch, share it, and there'll be more. And there's wonderful things too. There's this, somebody just uploaded a clock that's a little robot arm that draws the time and then erases it. Cuts. This is a really cool project. This is the RoboHand project. I'm going to cruise through some projects very quickly. This is a project, a community project to make prosthetic hands for kids. It costs about $5 instead of $20,000. And this is, normally kids don't get prosthetic hands, and so this makes it possible. Because they grow out of them like sneakers. If you're going to spend $20,000 on sneakers, you don't want to grow out of them. And this is just going, this is, that was Liam, this is Leon. He saw Liam's hand and he went to his school Makerbot and made his own. And now these kids go to school, instead of having amniotic band syndrome, they're Iron Man. He's adding lasers to his model. This is John Camp. This is parts for the James Webb Telescope that they made while the telescope was in the cryo chamber, saving like months and months of time because they were able to do work in parallel. There's 3 there. It started with one Makerbot, and then people were like, "Why do you get one? And then, why do you have a Makerbot on your desk?" Because he's like cranking stuff out, and now they're just proliferating like rabbits. This is a soccer ball made by Uncharted Play out of Poughkeepsie that you kick around all day, and it's got a battery and a gyro in it, and at night you can do your homework to it. This is a happy girl because she went to an amusement park and she's 41.5 inches tall, and so her dad made her little things to stick in your shoe to make her taller. Balance restored to the universe. This is Casey Hallgren. She is a badass designer who is changing the way that set designers make things. This is all made up of Makerbot. She also has a business on the side where she makes dollhouse furniture, so she's become an entrepreneur as well. That's hot. The Locomotors is just the coolest company that makes really cool desert rally cars, and they use a Makerbot in many ways on their production machines. We're infiltrating classrooms like crazy because we want to get Makerbots in schools to empower the next generation to be ready, to be digitally literate, and kick ass. And I'm actually going with the Warriors tomorrow to present Makerbot to Oakland Tech, which is going to be awesome. And now we're going to get into a conversation. That was fast. Thank you.
That was amazing. So will you commit right now to putting a replicator mini in all of our swag bags today?
Put me on the spot like Oprah.
Probably not going to happen. Maybe next year. So
I'll come back next year.
We've been hearing about 3D printing for 20 or 30 years. And the dream has always been to put these in people's homes. Do you believe we're there now? I mean, what needs to happen to get a replicator mini, not just into schools or startups or design firms, but into the homes of people?
You know, it's interesting. We solved the hardware problem. We're ready. It's real. We have the classic chasm challenge of the technology is there, but you lead a horse to water kind of a thing. And it's it's an interesting challenge because when we started, it was about teaching people what 3D printing is, and now the challenge is teaching people what 3D printing can be to them. And it's, when people get a Makerbot, they never go back. Like, once you have the superpower to make anything, you don't just give that up, you escalate. But it's one of those things where this year or early next year, we're going to hit the point where most people know someone with a 3D printer.
So last year was a big year for you. You were acquired by a company called Stratasys. You went from being kind of the leader of this open source movement and power movement to being owned by a company that is large, is a classic protector of IP. What has that transition been like for you?
It's one of those things where the combo made more sense than the separation. So, and also we just met with we really like the people, which made it make sense. And it's interesting though, like now I'm part of a public company, and if I make forward-looking statements, I can go to jail. So, and that's like kind of what I do. So, it's an interesting position to be in, and it's allowed us to accelerate and have more resources to empower more people.
Well, maybe on the question of forward-looking statements and futurology, what do you think the market looks like? Let's say in 10 years or in 20 years. What does 3D printing look like, and what do the devices look like?
Yeah, it's going to be really cool to explore that, and I can imagine a couple of years out because I'm designing that stuff now, but there's going to be a huge explosion of material science connected to this. Right now, we mostly use a material called PLA, which is a renewable bioplastic derived from corn. Smells good when you make things. And there's a whole frontier out there of what you can make things with that explores that. And PLA is really, it's a wonderfully dimensionally stable, it's very great material. We keep on, we're limited by the periodic table, unfortunately. So but there's all sorts of things to explore.
You mentioned manufacturing in Brooklyn, and I'd like to get you to talk a little bit more about that, because I imagine, like every company, you explored overseas manufacturing. What are the synergies, the benefits that you found in making your product here in the United States?
We're just so proud of that. We like to say that every Makerbot's made with a secret ingredient, Brooklyn pride, and it works. It's one of those things where we looked at it and we looked into how much it would cost to ship a Makerbot from Asia to the US, and it's going to be like $50 on the slowest boat possible. And then you add in the cultural challenges, you add in the IP challenges, you add in the long flights and having to split teams up, and it's really great because we have the design engineers and the mechanical engineers in the same room as the manufacturing engineers, and they argue every day anyway. So, better face-to-face than a phone call. It means that we can resolve things much faster. Literally, a mechanical engineer will be like, somebody will come up and be like, they're all breaking. What did we do wrong? And they'll go down and they'll just fix it before it gets off the line, rather than putting them all in boxes and having them arrive and then having to fix it.
So what do your manufacturing facilities look like now? How big is the operation?
So we have over 100,000 square feet in former munitions factories on the water in Brooklyn at Sunset Park. And it's awesome. And it's a lot of manual labor. These are assembled by hand. But you saw like the jigs and fixtures that we're making. It's all optimized as well. We expected it to take a Makerbot replicator to come off the line every 10 minutes. And it turns out that we have teams that are competitive. And we're actually like, I'm in the moment where it's like, okay, we're going so fast that I'm getting a little bit worried that we're missing something, but so far so good.
So we don't have a lot of time for this discussion, so I did want to ask you this. What do you make of the debate, for the idea that somebody might one day 3D print a gun? That always seems to come up in relation to this industry.
Yeah, it's interesting because it's actually been an American tradition since the Revolutionary War to make firearms. But there's actually way better ways to make them than with a 3D printer. And the thing is that there's so many more creative and wonderful things you can bring into the world with a 3D printer that I hate to give it much attention, because it's not terribly interesting once you get out of the mass manufactured hype of freak out that people want, that the media wants to have.
Is it even possible? Might it be possible one day? You're saying we shouldn't spend much time worrying about it.
Yeah, I mean, I think you have to worry a lot more about the person who just goes down the street and buys one off the street than you have to worry about somebody obsessing over it for weeks and weeks and weeks.
Okay, last question, since somehow we're out of time. If I walk into your apartment or house in New York, what's the first 3D printed item that I see?
We have a scanner in our retail stores, and where you can get your bus scanned. And I 3D scanned my daughter for the holidays, and made copies of her, like a 3D portrait for the grandparents and the family, and it just went over so well. And so I've got a bunch of those.
Great, thank you very much.
Thanks for having me.